Today's class began with the problem: if 6 people can do a job in 10 hours, how long will it take 5 people? Working at the same rate, of course. Working at the same rate and doing the same job. So most kids look at this and assume that it's proportion. And it is kind of a proportion. But when you think about it, 6 people taking 10 hours, if there are fewer people, it's going to take them longer. And we have to assume it's the same job. So 6 people working 10 hours each is going to be the same as 5 people working how many hours? 60 equals 5x. So it will take them 12 hours. And this is a real-life example of the idea of inverse variation. It's a type of proportion, but it's a proportion where as x gets bigger, y gets smaller. It means that you're multiplying to give the... So the general form of an inverse variation is any x times its y is equal to a constant. And we've seen a lot of this in the fact that rate times time equals distance. If I know that the distance is 120 miles and the rate is 60 miles an hour, it's going to take me 2 hours. If I'm going 40 miles an hour, it's going to take me 3. The distance won't change. It's the constant. And this is like the x and this is the y. So let's create a function machine where, for the equation, xy is equal to 12, just because 12 has a lot of factors. 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, 12, 1. These are all ordered pairs in it because 1 times 12 is 12, 2 times 6 is 12, 3 times 4. They fit the rule of x times y is equal to 12. We also have all of these numbers in negative. -1, -12, -2, -6, -3, -4, -4, -3, -6, -2, -12, -1. And those are just the integer solutions. There are things that are in between as well. So let's look at what a graph of this would look like. Sorry for my... Oh, I meant to import... Let's see if I can do that. Let's see if I can import my more exact graph. So here, camera roll. Oh, not bad. Gonna do that. Okay, so we've got 1, 12. Well, this is going to get off this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It would be somewhere up here. And then we have 2, 6. 1, 2, 3, 4, 5, 6. And then we have 3, 4. 1, 2, 3, 4. And then we have 4, 3. And then we have 6, 2. Oops, sorry. One, 2, 3, 4, 5, 6, 2. And 12, 1 is somewhere out here. So as you can see, this makes a nice little curve. And it gets infinitely closer to each of the axes, but can never cross them because if x were 0, anything times 0 would equal 0, and so it could never equal 12. And when I do the negative side of that, if I say -1, 12, well, that's way down here somewhere. -2, 6, 1, 2, 3, 4, 5, 6, and then 4, 3, 4, -4, -3, -6. So you see you have the exact mirror image, or as we would say, it's reflected over this line, which, as we talked about, is the graph of x y equals negative x. You don't need to know that. This is just a little trivia there. But it makes this shape, which is called a hyperbola. And that A is important because it's not a hyperbole, it's a hyperbola. So keeping times its y is always equal to the same number, called a constant, just like before when I said 1/12 is an ordered pair. And that they're an ordered pair because 1 times 12, if I'm going back to this formula, x times y is 12. 1 times 12 is one of the ordered pairs, and it's going to equal any of the other ordered pairs when you multiply them together. So not only is this the general form of the equation for an inverse variation, since any x times its y is always equal to the same number, any x times its y, times its y, is equal to any other x times its y. As we saw here, this would be like x sub 1, y sub 1, x sub 2, y sub 2. And notice that when we're doing this, it's multiplication. The x and y are multiplied together. One of the things kids have most trouble with is remembering the difference between direct and inverse. And you can think of it as direct begins with D, and it talks about division. Inverse is about multiplication. Any x times its y is equal to any other x times its y. So in some of your problems tonight, it might say x sub 1 is 2, y sub 1 is 9, x sub 2 is 6. Well, what is y sub 2? And the way you'd set that up is you'd say any x times its y is equal to any other x times its y, and we'll just call it y to make it interesting, easy. 18 is equal to 6y, and that means y sub 2 is equal to 3, and this makes sense because 2 times 9 is the same as 6 times 3. When you encounter word problems, you just have to be careful of the words, but setting up the equation is the same. So I'm going to read you a problem that's an example in your book, along with the directions in there. This is at the top of page 400, and please note that the directions say, for each inverse variation described, state the formula and a proportion. We are only going to be doing the formula. So in the example, the height of a cylinder, and they say a right circular cylinder, but for our purposes, just to make, and then we're going to call that h, varies inversely, and right away you've got that clue that you're going to be multiplying the two variables together for a constant, as the area of the base, and we're going to call that A of the base. Actually, they use a capital A, and that'll make it look less like the word, of the base. So, a cylinder 6 inches high has a base of 20 inches squared. Cylinder, I'm trying to get to electives here. Cylinder 6 inches high has a base of 21 square inches. So, we're not really asked to find anything, we're just asked to give a formula. We know that any x times its y, and in this case, any h times its area, height times its area, because the height varies inversely as the area, equals any other height times its area. And in this case, we're given 6 times 21. So the formula is just HA is equal to 120. So a word problem might say, 3 friends, it's just like our word problem of the day. 3 friends on a fishing trip pay $100 each to share the rent of a cottage. So 3 friends of a cottage pay $100 each for a cottage. The cost per person varies inversely. This is the important part. Cost per person varies inversely with the number as the number of people sharing the rent. And this makes perfect sense because the people renting the cottage are going to be charging a set price. That would be the constant. And if 4 people go, that's going to cost less than if 3 because you're dividing them among 4 more people. So it says how many people would have to share the rent? How many to cost 60 per person? How many needed to cost 60 per person? Okay, Mary, you can write. To cost $60 per person. So we know the cost per person varies inversely as the number of people sharing it. So in our given statement, the cost per person is $100, varies inversely as the people sharing the rate, the people. So cost varies inversely as people. Friends are people. 100 times 3. And then, so that's our first thing. And now the other thing, we know that this cost is 60. And the thing we don't know is how many people or friends. So we're going to call that x. So 300 is equal to 60x divided by 60 divided by 60. And that means it would take 5 people. The one last thing I do want to, sometimes in the basic things that you're trying to do, it might say, I don't know, let's say x times y equals 1. Well, you're asked to find a bunch of values and then graph them. So clearly you know that 1 and 1 works. But those are the only integers. So you then have to get, I don't know, you have to get a little bit fancy and say, what if I have 1/4? Well, that would be 4, because 1/4 times 4, or 1/2 times 2. So you're going to have to use fractions in a situation like that. And don't forget, you also always need the negatives. -1 and -1. -1/2 and -2. -1/3, you might want to put them in this order. -3. So that's just a final thing. I know that kids often have questions about that. Or if your problem first started out as x over 3 equals 4 over y, you might say, wait a second, I don't see that. That is not something in the form of an indirect variation. However, if I cross multiply, I can see that x times y equals 12. Ooh, how convenient. One we've already looked at. That's all.